Okay, let me introduce you to scientific notation, where we're going to do a couple of examples. What is scientific notation? Well, it's a way to represent very large numbers in a more kind of compact way, or very, very small numbers in a compact way. You know, sometimes a large number may have lots of zeros. Scientific notation is the way to go. And if it's got too many decimal places and it's really tiny, then scientific notation is the way to go also. So we've got a couple of examples. First one is only 3 digits. It's a normal number. We're going to transform it into scientific notation. So we're working with a simple number, 251. So let's write that just for learning purposes into scientific notation. Now, what's the first step? The first step is we want to write a digit first, move the decimal place in such a way that that turns into a number that is between less than 10 and greater than or equal to positive 1. So it's got to be a digit that's in there. So to do that, I'm going to turn this number, 251, and I'm going to move the decimal place, which we can't see. Essentially, it's right here. We don't usually write it, but if you have a whole number, the decimal place is usually there. We move it this way until we get a digit between 10 and 1, as we've indicated. So I'm going to move it to the left. So 1, 2. So the new decimal place goes there. So essentially the number is now 2.51. Is that between, is it less than 10 and greater than or equal to 1? Yes, it is, 2.51. Now that number is smaller than 251, obviously, so we need to balance it. So we're going to multiply it by, and this is the thing about scientific notation, we multiply by 10 to some exponent power up there. Now what's the exponent power? Very easy. We moved to the left, did we not? How many places did we move to the left? We moved 2 places, did we not? That way. So that means up here we write to the power of 2. So that's scientific notation. 2.51 times 10 to the power of 2 is 251. So let me just write it again. 2.51 times 10 to the power of 2. Okay. Now you may be thinking, well, that's only a 3-digit number. What happens when you have, as you said earlier, a very large number, lots of zeros, and you want to make it more compact in scientific notation? Well, let's do an example like that. This example, as I unveil it, is in the millions. So it's relatively large. It's 6,358,000. Let's make that into scientific notation. So what's the first thing we want to do? Well, the first thing you want to do, like we did here, is come up with a digit or a number that is between less than 10 and greater than or equal to 1. So that means I've got to move the decimal place from here all the way to there. So let me just write it out again. So I'm just going to mark it out. We're going to go from here, and we're going to move it all the way to here. So let's move it now. Let's count. We're moving to the left again. 1, 2, 3, 4, 5, 6. Decimal point goes right over there. So essentially this number, 358, is now into 6.358. Is that between, well, is it greater than 1, greater than or equal to 1, and less than 10, is it? Yes, it is. 6.358. Then we multiply by 10 to the power of what? Well, we moved how many places to the left? I'll count them again. 1, 2, 3, 4, 5, 6 places. So that means up here we write 6. So now this essentially is the same number as that, written in scientific notation. And there you go. Thanks for watching.